All right, good morning, everyone. Thank you very much for tuning in for another Concrete Ontario webinar. Today's topic is cold weather concreting. Before we do get started, as always, your facilitators are myself, Alan Carey, Technical Services Engineer for Concrete Ontario, and we also have Bart Canters here, who's the President of Concrete Ontario, who will be presenting some of the information this morning. As always, housekeeping just for some new attendees in case you're new to our webinar process. It's going to be approximately a 30 to 45-minute webinar, and we're going to leave some time at the end for some questions. All participants are muted and will remain that way for the entire webinar. If you do have any questions, please use your GoToWebinar questions pane at the right side of your screen and type in any questions that you may have. We will address all questions at the end. This webinar will be recorded and posted on our YouTube channel. And to make it easier for attendees, we're going to send out a PDF version of the presentation, as well as a link to the YouTube video to make access easier, and you can share it that way as well. Your presenter today is Andre Mirzan. Andre is a civil engineering graduate and a professional engineer with the PEO. He has been working with Dufferin Concrete and Ontario Ready Mix, which are both divisions of CRH Canada Group, for the last 11 years. And is currently the Manager of Quality Assurance for Dufferin Concrete West District and Ontario Ready Mix. Andre is a proud member of the Concrete Ontario Technical Committee and is always looking to promote the production and delivery of consistent quality concrete to the construction industry. Thank you very much for coming in this morning, Andre. We always appreciate your help.
Thank you very much for having me, guys.
In terms of the agenda today, we're going to talk a little bit about the cold stress guideline, which Concrete Ontario put together and updated last year. So Bart Canters will be looking after that portion. And then we're going to move into the cold weather concreting presentation, which is going to have the definition of cold weather. We're going to talk a little bit about rebar and formwork. We're going to talk about different concrete temperatures and different specifications. We're going to get into placing concrete in cold weather, some of the protection periods and protection methods that are used. And we're going to outline a brief protection plan of something that should be available for each project. And then we're going to summarize with some key points to success. Having said all that, I will turn it over to Bart Canters to talk a little bit about our cold stress guideline, which we put together last year.
Thank you very much, Alan. Good morning, everyone. Our Health and Safety Committee meets 3 to 4 times per year. We're always looking for members who want to contribute to the Health and Safety Committee. So if anyone is interested in joining the Health and Safety Committee, please contact Alan or myself. One of the critical documents that this committee has put out and updated recently is the cold stress guidelines. So it's about a 12-page document that goes through and deals with a lot of cold weather issues. So the purpose of this guide really is to identify best practices to minimize the risks to health and safety of workers. So really with drivers, plant operations people, quality control personnel, we've got more than 4,000 employees working out in cold weather conditions every day throughout the year during our cold weather periods. So really the purpose of this guide is to identify some of the critical issues that members need to keep in mind and some of the steps they can take to provide worker safety. So the next slide. So some of the key factors that are identified in this document include factors that contribute to heat loss. So temperature. So again, as the guide indicates, doesn't need to be below 0 to get into cold stress issues. So again, cold temperatures, once we get down below 10 degrees C, then we can run into issues. Wind chill is a very significant factor when it comes to working outside, and we'll deal with that in a minute and address it. Humidity is another key consideration. So water conducts heat away from the body 25 times faster than air. So in cold weather, it's critical that workers not be wet. So things like sweating can have very big impact on the heat loss when it comes to work protection. And then providing the proper protective clothing. So clothing that's suited to the work, ideally clothing that wicks moisture away from the body so it's not sitting on the skin, and is sized properly so that it provides proper protection. So we'll jump a little bit into wind chill, and here we're dealing with it in regards to workers, but we'll talk later about concrete as well. So you got a basic table here that shows the 3 danger zones. So little danger, danger, and great danger. So we'll just explain wind chill very quickly. So if we look at the first row across the top, when there's 0 wind, so the wind speed is 0, whatever the ambient air temperature is, that's what the wind chill temperature is as well. So when it's 4 degrees with no wind, it's 4 degrees, that's what the body feels. When it's -12 with no wind, that's what the body feels. As the air temperature picks up, or sorry, as the wind speed picks up, then we get into a colder effective temperature. So again, when you're looking at the table, if I jump in at -1, our first temperature, when the wind's blowing at 40 kilometers per hour, if I come down to 40 kilometers, come across, the air temperature is at -1, the effective air temperature is -18, looking at this table. So really what you see is that as the wind speed picks up, you have a colder effective temperature. And really what the table is broken down into is once you get into -30, you're in the danger zone and exposed flesh can freeze in 1 minute. Once we get to -60 effective temperature, then we're in the great danger zone and it can freeze in 30 seconds or less. So again, those are the key areas. So we'll come back to that later when we talk about concrete. The guide also deals with cold stress illnesses. I'm not going to bother going through all of them. They're explained in greater detail in the document itself. So respiratory damage, hypothermia, frostbite, etc. The guide goes through and explains what some of the risk factors are and the steps that you can take to address those issues from a safety standpoint. So jump into the next slide. So some of the factors that can contribute to cold stress from a health and safety standpoint, dehydration. So again, if workers dehydrated, then that can increase the effect of cold stress. Acclimatization, so ideally a gradual increase in the amount of work as we're working in cold environments to build up body temperature slowly. General state of health, diet, drugs and medication, clothing, all those factors can have impacts, and the guide goes through and talks about the various steps that you should take to address those issues. So finishing this off, we just encourage everyone that's participating in the webinar today to download from our website the cold stress guideline, have a look at it. There's great information in there that you can use for safety talks within your own company, and the Health and Safety Committee would encourage you to review the information. That's it for that guide.
And along with the presentation and the YouTube channel link, we can include this guide as well to make it easier for people to access the guideline. Now we can turn it over to Andre.
Okay, good morning, everyone. Just going to take you over through the cold weather best practices for winter construction. We'll start off with the definition of cold weather. It's important that everyone realizes when we need to apply proper concrete protection to address cold ambient conditions on job sites. According to CSA 23.1-14 Clause 7, it defines cold weather when there is a probability of the air temperature falling below 5 degrees Celsius within 24 hours of placing. And that's based on the forecast by the nearest official meteorological office. So if you are a contractor pouring concrete in a specific location, best practice would be, especially if you're in cold weather ambient conditions, to check with the weather network or check the weather on TV and understand what are going to be the placement conditions or challenges with the weather factors in the next 24 hours from the time you're placing the concrete. If you look at our Ontario Provincial Standard Specification, the MUNI 904, the November 2012 edition, the definition there of cold weather also looks at an ambient air temperature at or below 5 degrees Celsius. And that's also considered to exist when the ambient air is at or is likely to fall below that temperature within 96 hours or 4 days after completion of concrete placement. Temperature refers to shade temperature. So what they're basically saying here is that in the next 4 days, if there's potential that it's going to drop below 5 degrees C, the proper concrete protection mechanisms and procedures need to be put in place to address the cold ambient conditions. When we look at preparing the rebar and the formwork on the job site and getting ready for a concrete placement, it's very important that all snow and ice shall be removed before concrete is deposited on any surface, whether it's a metallic or wood or subgrade. Subgrade formwork, rebar, etc., need to be kept above freezing. And also, what we're noticing is when that is put in place, especially if it snowed the days before, if there was ice or frost on the formwork or subgrade, once you thaw out that ice and frost, you will have a little bit of water ponding. So it is best practice as well to make sure you remove all the water from any formwork before you start with concrete placement. Calcium chloride or other de-icing salts shall not be used as a de-icing agent in the forms. Although they're effective in melting ice and preventing frost and freezing, they do damage concrete durability and performance, so we don't want them in the forms to make sure that there's no foreign contaminants when we place concrete. What we do know through history is that at low temperatures, concrete gains strength and sets very slowly, especially if it's left unprotected to the cold ambient conditions. And because of that, it must be adequately protected from freezing conditions. Concrete that is allowed to freeze while in its plastic state can have its potential strength reduced by more than 50%, and its durability properties will be dramatically reduced. So it's best that we follow the proper practices to make sure that concrete does not freeze when placed in winter construction. Concrete shall not be placed on or against any surface that will lower the temperature of the concrete in place below the minimum value that we're going to see in table 14. So what happens is if you place concrete against a cold surface, it will absorb a lot of the heat from the hydration process and from the internal concrete temperature that will increase bleed times as well as set times for concrete. And that's something that you want to avoid in winter construction, and we'll be discussing that shortly. CSA Table 14 defines the permissible concrete temperatures of placement, and it looks at the minimum thicknesses of concrete sections or elements. So most of our construction is either less than 300 millimeters or between 300 and 1 meter. The minimum concrete temperature placement to ensure proper setting, strength and durability is 10 degrees C, while the maximums vary between 30 and 32. Once the element gets thicker, now you need to worry about the heat generated in the core of the element. So lower, typically maximum and minimum temperatures are specified, but you'll notice there that we don't go below 5 degrees C, trying to keep those temperatures above the freezing point. Now moving into placing concrete in cold weather. Again, we discussed this, removing all ice and snow for the subgrade or formwork is very important. How does this get achieved on job sites? Typical construction follows either the use of insulating and tarps or other equipment, as well as heating surfaces to make sure they're kept above freezing. So it's very important that the necessary supplemental heat required is applied to maintain everything at minimum 5 degrees C, well before concrete placement, during and continuing with the concrete process. What we need to watch out for, especially in enclosed areas, if you are using combustion equipment sources such as gas heaters, power trowels, or other machinery, you must make sure that you're adequately ventilating the carbon dioxide to prevent carbonation of freshly placed concrete. So that is a common concern, and we'll see some photos on the next slides that show some vent areas. It's also important that concrete is ordered at proper concrete temperatures between 10 and 25 degrees. The concrete industry as a whole, between November 1st and April 15, they do heat their raw materials. So they provide hot water in the concrete as well as heated aggregates to ensure that concrete temperatures is kept at a proper level to ensure proper setting in winter construction. Concrete should also be ordered using the lowest practical water slump, and the benefit of doing that is that will reduce bleeding and setting time, and goal being that you want to have as quick as possible setting characteristics to allow for proper finishing on the job site, so that concrete can be protected and prevented from freezing. Contractors also prefer the use of chemical admixtures that the concrete suppliers provide, such as accelerators, and they are used to reduce set times and also to accelerate early strength gain of concrete in particular where you're looking to strip the forms early. As well, if you are going to order at a low practical slump, if you still want to maintain proper workability and flowability to help with ease of placement, super plasticizers are also highly recommended to go alongside with the accelerators. There's two types of commonly used accelerators in the marketplace. We have a calcium chloride accelerator, which is very common and effective in winter construction. But however, given the chloride component of the accelerator is not recommended for reinforced concrete that contains steel or rebar, and as such, the equivalent accelerator for that is a non-chloride accelerator, in particular in reinforced concrete elements where corrosion is a concern. However, with the accelerators in the concrete mixtures, we need to be mindful of the fact that they do not prevent concrete from freezing, and their use does not preclude the need for appropriate curing and protection from freezing. Concrete is not antifreeze. It will freeze if it's not adequately protected from freezing. So just put up two photos here to show some typical winter construction. The top left corner shows an elevated concrete element being placed. You can kind of tell in the corner of the photo some of the heat coming from the concrete, so that's a good indication. It means it was delivered at proper concrete temperature. But once the contractor expedites the placing and finishing of the concrete, they need to get on making sure they protect it and they cure it for the appropriate amount of time and the appropriate concrete temperature, which we'll be discussing shortly. On the bottom right-hand corner, that is an enclosed floor level in a mid-rise building, low to mid-rise building, and what you'll notice is the airtight enclosure provided by the plastic sheeting on the outside with a couple of open spots there that are used for ventilation to ensure that we prevent carbonation. When you have this type of enclosure, you want to make sure that it's airtight and it's able to withstand any wind and snow loads that may arise during the construction process. Continuing with placing concrete in cold weather, the surface of the concrete should not be allowed to dry out while it is still plastic, as this may lead to plastic shrinkage cracking. Although this phenomenon is mostly observed during the summertime when you have dry and windy weather, it could happen in the winter because we do have quite a few windy days with the wind chill, as well as if you don't provide adequate protection and you expose that surface for a longer period of time, this effect can still occur. So it's best that you prevent it from drying out. Wet curing methods are typically not recommended during cold weather conditions. While they're ideal during the spring, summer, and fall, when it comes to ambient conditions dipping below the freezing point, these are not recommended. We'll talk about some of the applicable methods for concrete protection and curing. The reason they're not recommended is that they do not have, once the concrete is exposed to the cold ambient condition, it will not have sufficient time to air dry before exposure to freeze-thaw cycles. And if you don't allow the concrete to air dry appropriately, and the recommended period is typically 30 days or 1 month, it may lead to potential concrete scaling issues. Very common in the residential market, exterior concrete flatwork such as sidewalks, driveways, and curbs should not be placed in service until the concrete has reached a specified strength. At a minimum, if you have to place it in service, the recommended MPa that the concrete needs to reach is 20 MPa before exposure to freeze-thaw cycles. What happens with these type of elements in the residential market is that the mechanical abrasion of snow plows in the winter, trying to clear the snow off the sidewalks and the curbs before the concrete was able to achieve a specified strength, can result in significant damage to the concrete surface. As well, if you expose it early to de-icing chemicals, those have a detrimental effect on the surface finish of exterior concrete. And that's why we state that it should not be exposed to de-icing chemicals in its first year of service. Where icy conditions exist or will occur on the sidewalk and curbs, preferably the use of sand for traction is one of the methods recommended rather than using any chloride-based de-icing chemicals. Once the element is protected and a decision is made to remove the protection and expose it to the elements, you want to make sure that you avoid thermal cracking. And that's because you're suspending the heat retention of the element, and once that heat is suspended, concrete must not be allowed to cool at a rate outside the limits stated in Table 20 of CSA 23.1. And we're going to go over that table shortly after the slide. Special care must be taken with concrete test specimens used for acceptance of concrete, as they must be kept in a controlled environment that maintains the temperature between 15 and 25 degrees Celsius as per CSA 23.1.2 requirements. This is something we always gonna need to be wary of and mindful of on job sites. When it comes to concrete cylinders used for acceptance between the contractor and the third-party testing lab on the job site, they need to make sure that an appropriate enclosure is identified that has a controlled environment that maintains those concrete temperatures. Otherwise, those concrete samples exhibit the risk of freezing, damage in transportation, and they won't be building the appropriate strength and durability for validation and acceptance down the road. So looking at CSA Table 20, the maximum permissible temperature differential between concrete surface and ambient to minimize cracking, it looks at a wind factor of up to 25 degrees Celsius. The way we read this table is we first identify the thickness of our concrete element, and based on the thickness and we do a quick calculation looking at the length to height ratio of structural elements, and based on that length to height ratio, we identify the permissible temperature differential between the surface and the ambient to minimize thermal cracking. And what that will require, and we're going to see it shortly when we look at the cold weather plan and the OPSS specification, is that you may sometimes need to apply multiple layers of insulating blankets or protection to the concrete element that you will need to peel off gradually to ensure that you maintain that temperature differential. Looking at the protection period, on the job site, you want to make sure that all materials and equipment needed for adequate protection and curing are available and they are on hand and ready to use before each concrete placement is started. Curing shall begin immediately following the placing and finishing operations and shall provide the temperature and moisture conditions for the period of time necessary for concrete to develop its strength, durability, and other properties. So you have to identify the appropriate method of curing given the construction and the conditions around the concrete element. Materials and equipment should be in place to protect concrete both during and after placement from early age freezing and to retain the heat generated by the hydration process. This is a very important element of concrete placement and finishing, because if you are unable to retain that heat, the concrete will take longer to set and it will show excessive bleeding that will lead to potential surface issues down the road. The concrete temperature shall be maintained at no less than 10 degrees Celsius throughout the curing period. And we're going to be looking at those curing periods shortly in accordance with Table 2 and Table 19 of CSA. If you look at Table 2 of CSA, based on the classes of exposure, for normal concrete, we have different curing types or curing regimes, as we call them, 3, 2, and 1. And each one of them is identified further in Table 19. And the timeline as well as the strength development is explained. So if you're looking at curing type of 1 for basic curing, which is for 3 days at temperatures of 10 degrees C or higher, and that is for the time necessary for the structure to attain 40% of the specified strength. The most common type of curing is number 2, additional curing, in particular for exterior flatwork applications, and that's for 7 days at ambient temperatures of 10 degrees C or higher, or for the time necessary to attain 70 to 75% of the specified strength. Not always easy to do in winter construction, but we need to be mindful of this and make sure that that concrete has appropriate temperatures to reach its strength and durability. And then curing regime 3, extended wet curing for a period of more than a full wet curing period of 7 days or at 10 degrees C or more for the time necessary to attain 75% of the specified strength. This is not always possible during winter constructions, given that it's a wet curing period, which is why additional curing is the preferred curing method specified in winter construction. Okay, looking at some of the protection methods, especially when it comes to heated enclosures, when you are protecting the concrete element that you're going to be placing or curing over a specified period of time, you want to make sure that the Heated enclosure is constructed to withstand wind and snow load and shall be reasonably airtight. The heat that shall be applied to the enclosure by forced hot air using a salamander heater, for example, stationary heaters, hydronic heaters, or other heaters of various types. You want to make sure you provide that supplemental heating to maintain proper ambient and concrete temperatures. If you're using combustion heaters, as discussed before, you want to make sure you vent them to the outside to prevent any concrete carbonation. When it comes to doing flat work constructions, the type of protective cover and the amount of insulation required to cure concrete properly in cold weather shall be determined on the basis of the expected air temperature and wind velocity. So wind chill is a significant factor that we need to worry about when it comes to, in particular, to concrete or to surface areas that are exposed to the wind. The size and shape of the concrete structure also determines how that concrete element is going to set, the amount of heat it's going to generate, and the amount of protection it requires. And the amount of cement in the mix also makes an impact on how quickly the mix sets and the early strength development that it demonstrates. You will always need to be mindful of corners, edges, or any thin sections of a concrete member, as they are the most vulnerable locations in an element, and they will probably require more protection than the rest of the structure when looking after protecting the concrete. When concrete reaches a compressive strength of 3.5 MPa, it will normally have sufficient strength to resist early frost damage. So we need to make sure that it reaches that minimum compressive strength. However, if you're going to be removing the protection and insulation of the concrete element, it needs to reach a minimum of 75% of the strength to make sure it withstands freezing and thawing cycles. Looking at the municipal OPSS 904 table 3, it provides a little bit of guidance when it comes to protective covers and insulation based on different ambient conditions going as low as minus 20 degrees. The notes provide some of the definitions for the PM levels identified in the table. So depending again on the thickness of the concrete element, OPSS specifies a certain R value that needs to be met by using moisture vapor barrier as well as insulation to make sure we hit those R values to ensure proper concrete temperatures and setting during the protection period. Cold weather protection plan. So very common, in particular if you're doing MTO work, the MTO will require a temperature control plan. A lot of structural projects as well, the owners will ask, or the consultants for the contractor to demonstrate an appropriate cold weather protection plan. So that must be submitted to either the contractor administrator or to the engineer on record or the owner, a minimum of 1 week prior to commencement of placing any concrete that requires temperature control for review of compliance with the contract requirements. The plan shall include what are the methods in place for monitoring and controlling concrete temperature, as well as the temperature difference before, during, and after placement. Again, the concern there being thermal cracking, and that's for all concrete subject to cold weather. At a minimum, the temperature control plan should include all of the following. Concrete element for which the plan applies is to be identified. Is it a column? Is it a slab on grade? Is it a floor? Is it a wall? What is your temperature monitoring system that you're going to have in place to monitor these temperatures, including the locations and depth, number of thermocouples, if you're going to be installing thermocouples to monitor internal and surface concrete temperatures, as well as the frequency of recording these temperatures. Method of ensuring concrete temperatures and temperature difference are maintained for the duration of the protection period. Any alterations that are going to happen to the work schedule, to the production schedule, delivery schedule, and time of placement for temperature control purposes need to be identified. You always want to have a backup plan in case things don't go as directed. Any modifications to mix designs for temperature control purposes can be implemented. You can look at ordering mixes with accelerators, mixes that set under cold ambient conditions, or early strength gain mixes to help with the temperature control plan, or any other specific measures that you want to take that will help the concrete set, cure, and develop the proper strength and durability. And when it comes to removing the protection from the concrete elements, you want to make sure that the method of withdrawal is clearly identified and that you are doing it appropriately to prevent any thermal cracking or any other damage to the concrete element. Type of installation is also very important, and it is defined by the R value. So you need to be mindful of that when you purchase or use a thermal insulation. The number of layers are also important. Sometimes you have to apply more than one layer of insulation to ensure you have the appropriate R value. The submission for cold weather protective measures shall be accompanied by the type of insulation, samples of insulation you're going to be providing, if requested. And the type and layout of heaters and any type and extent of housing that you're going to apply needs to be identified as well. So just to summarize everything, I want to list a couple of key points to a successful concrete placement during winter construction. If the concrete element you're going to be pouring is going to exhibit some exposure to moisture and freezing and thawing conditions, you may consider going with air entering concrete. Keep surfaces in contact with concrete free of ice, snow, and at a temperature above freezing prior to placement. Place and maintain concrete at the recommended temperature. Look at placing the concrete at the lowest practical slump, and that's again to avoid excessive bleeding and reduce set times. Protect plastic concrete from freezing or drying. Again, that has to occur during and after placement and for the period of time identified for proper curing. Protect concrete from early age freezing and thawing cycles until it has attained adequate strength. And as much as possible, limit rapid temperature changes when protective measures are removed. So these key points of success, I've summarized them from a best practice document by the National Ready Mix Concrete Association, Concrete in Practice 27, Cold Weather Concreting. A couple of questions that people on the call may ask related to cold weather construction, and we have a couple of photos here that we want to go through just quickly. Question that can be asked is, what can you infer from looking at the cylinders? And one of the things you can tell is that obviously when these cylinders were cast out on the job site, they weren't adequately protected from freezing, and you'll notice that the cylinder in question here has developed some ice lenses, which will contribute to very low compressive strength gains and will probably fail from meeting the specified design strength. Now, when this happens, if you don't identify this and alert the general contractor and the owner, there will be a lot of anxiety and questions about the quality of the mix applied. So proper curing and protection is instrumental in ensuring that the concrete reaches its design strength and durability. This is a typical residential construction. We're looking at the photo on the left shows the foundation walls. And what we see here is during the cold weather conditions, when you strip the forms from vertical structures, given the high surface area that you have, the concrete will be exhibiting very rapid temperature loss. And if it wasn't protected sufficiently to reach a minimum the minimum 75% of the specified strength or the required strength for stripping the forms, then that concrete will take a long time to develop proper strength and durability. The concern with residential walls is that when it comes time to backfilling the wall, if the concrete element hasn't reached sufficient strength, there's potential for structural cracking from the backfill operation. So you want to make sure that when you're doing residential walls, that you are protecting the concrete, you're ordering the right mix, and that it's giving you the appropriate strength and durability to be able to strip and withstand freezing and thawing cycles. And on the right, the gentleman there, they're currently in the process of placing a footing for a residential home. You'll notice the hay there in the middle. So what they've done here most likely is they've had the hay on the subgrade, trying to keep the subgrade warm. It's not doing much. You know, when you use hay as an insulating element, what you want to do is you want to make sure that it's wrapped in plastic sheets so that there's no airflow through the hay, and then place that on the subgrade, or you can even use that on top of residential walls for protection. They tried. You got to admire their effort to keep the subgrade warm, and then they proceeded with the footing. So the question becomes now, when that footing is placed, are they following the proper practices for concrete protection to make sure the concrete sets properly?
So what you're saying is sprinkling a little bit of hay on top of the walls doesn't create a protective barrier that's going to protect the concrete? That's
correct, yeah. Okay. The hay needs to be together, and it needs to be insulated in a plastic sheet to ensure proper to offer some protection in that type of application.
So another common question that we get at the association relates to wind chill, and we talked about that before. So maybe looking at the picture on the left, we'll go through a couple different scenarios. So let's say in scenario 1, the ambient outdoor temperature is +5, but with a really high wind value, the effective wind chill is -10. So the question that often comes up is, will the concrete freeze in that scenario? So the quick answer is no. So when it comes back to wind chill is really what is the effective temperature felt on really what we're talking about is human skin. So the effective temperature that's felt is equivalent to no wind blowing and it being -10. So what happens in that situation is the residential house wall is losing heat to the ambient air temperature like it was -10, even though it's +5. But physically the wall can't freeze. The outside air temperature is still +5. It's going to lose heat. So if the wall starts off at 30 degrees C, it's going to lose heat like crazy, but it can't drop below 5 degrees C because that's what the actual ambient air temperature is, but it's going to lose heat much more quickly. If I take another scenario where the temperature is at -10 and we have the wind blowing again and the effective wind chill is -30, now definitely the concrete can freeze. So again, the concrete's ultimately going to drop down to -10 and stop at that point, but because the wind is blowing so hard, you're losing heat like the temperature was -30 with no wind. So that's just a quick review on the wind chill. So wind chill affects how quickly the concrete loses heat. So it does have a big impact when it's exposed, when you have a big exposed surface like in those pictures.
Okay, this is an old graph that we have from ACI looking at these concrete temperature as well as the ambient temperature and when is the best time to remove the formwork. So I apologize that it's in Fahrenheit, but the 36 the temperature differential identified as 36 Fahrenheit is our 20 Celsius limit that we have in CSA as well. So what it's saying is if the inside temperature is an appropriate level and it's within the 20 degrees and you proceed with form removal, and that concrete afterwards is going to suffer rapid temperature loss, and the temperature differential is more than 20 degrees, then you risk running into thermal shock and cracking of the concrete. So what you want to do is be on the dotted line where you're slowly removing the layers of protection while ensuring that the temperature differential is maintained at 20 degrees C or less, or based on the length to height ratio of your element following the CSA table 20 that we looked at earlier. This is a recent photo video that was taken of an interior slab on grade placement on a nice sunny day. However, the ambient outside was around -1, -2 degrees. So this is freshly placed concrete inside a small commercial building. And what you're seeing in this photo is the mezzanine on top received a little bit of snow accumulation from the night before. And what had happened was with the sun shining on it, it melted, and then the water was literally dripping down on the freshly placed concrete. So, you know, while the ready-mix supplier provided the ideal mix for winter construction, it's unfortunate that proper protection was not followed here once the slab was finished. And that's something that you don't want to see in winter construction, because then you'll have to explain and address what's going on with the concrete surface. Why am I seeing paste washout? Why isn't it as durable as I was expecting it to be? And again, it all stems from the lack of protection of the concrete surface. Any questions for us?
Okay. We do have just a couple here. One is, if you do order an accelerated mix, and do you still need to prevent it from freezing, or do you need to properly protect it after you place it? It does have the extra cement, maybe chemical admixtures. Does that actually prevent it from freezing, or are you done with protecting it at that point?
No. So you still have to follow the appropriate cold weather concrete practices. The advantage of that is that you are ordering the appropriate winter mix that will help the concrete set quicker, as well as provide early strength gain. But ultimately, no matter what accelerators you put in your concrete, the concrete is still prone to freezing. So you need to follow the measures that we discussed during this webinar to ensure that it's protected from freezing.
Okay. Next question we often get from municipalities that are still trying to place curb and sidewalk in December. What steps can they take to try and avoid scaling issues when placing curb and sidewalk in cold weather?
The first step I would take is, if a contractor is forced to place concrete in these cold weather conditions, again, he needs to be mindful of the conditions and understand best practice for cold weather concreting. But ultimately, what would help with this is ordering the appropriate winter mix to ensure that it sets and gains strength relatively fast. And then for curb and sidewalk, they need to be protected to make sure they reach at least 20 MPa, as we mentioned earlier, before exposure to freezing and thawing cycles. But ultimately, if a contractor is forced into placing this concrete, in my mind, a conversation should be had with the municipality or the home builder or whoever is asking them to do it, to make sure that they understand the challenges and the consequences of placing concrete this late in the season.
Yeah, so it's always the challenge between schedule and actually getting the performance of the concrete that you're looking for. It seems to always be a challenge with municipalities. We do have one more. What are typical methods of measuring concrete surface / internal temperature after placement?
Great question. So there's multiple ways you can do it. You can use your regular concrete thermometer that you can stick into the concrete surface to read the temperature. We are using sometimes infrared guns as well to monitor concrete temperatures and concrete surface, as well as the subgrade temperature before placing the concrete. If you have thermocouples installed in the concrete element, those will provide readings of the concrete temperatures. So there's a couple of tools out there that you can use to monitor this and understand how your concrete is curing and at what temperature it's at.
Yeah, we often get questions from municipal residential inspectors on how do I verify concrete temperature, and our simple answer is that Part 9 of the building code requires the concrete to be kept at 10 degrees C. And while an infrared thermometer is not CSA approved, it's $30 at Home Depot or Canadian Tire, and it will tell you quickly whether the concrete is at the necessary temperature or not.
Seems to be all the questions for today. Again, thank you very much, everyone, for tuning in this morning. It's a very important topic, especially with the winter months approaching. Seems like they're already here today, -5 or 6 today, but we need to make sure that best practices are always followed. Thank you, Andre, for coming in this morning. You really provided a great overview of how things are supposed to be done properly.
My pleasure.
And hopefully people will learn something today. In terms of our upcoming webinars, we do have one in January 17th, and it's preparing for MOE plant inspections. We will have 2 consultants coming in to talk about ECA applications, air and noise. They're going to provide an overview of what are some of the challenges that ready-mix producers are experiencing. And then in February, we're going to be looking at seasonal loads and how the association can help members with that aspect. But again, thank you very much, everyone, for tuning in. And we'll be sending the information to you later on this week, as discussed earlier in the webinar. Thank you, and have a great day.